The other thing that we need to consider is something called the project value at risk. And what we're trying to work out here is how much of the project is likely not to come through with this particular value. So if we've worked out the net present value of the project, how likely is it that those results might not be what we were hoping for? And one of the things that we have here is when you work out the net present value and you work out the standard deviation, what you're accepting is the fact that you might not get that average net present value that you were hoping for, and there is a probability of being plus or minus the standard deviation that we were considering before. The thing is, over time, what we end up with is these volatilities will increase, and therefore there's a greater and greater risk that you won't end up with that net present value you were hoping for at the end. Now, to actually work out the project value at risk, what we can do is look at how the volatility changes over time, and we can do so by looking at this formula. The first part of the formula represents the standard deviation over the longer period of time. The second bit represents the standard deviation over the shorter period, and the square root of t, where t represents the time period between the short and long period. But not in terms of number of months or number of years, but how many times the short period goes into the long period. For example, if the long period was 1 year and the short period was 3 months, then t would actually be 4 because there are 4 3-month periods in 1 year. So if we consider an example, the expected annual cash flows of a project are $250,000 and the annual volatility of the cash flows is $24,000. Assume that each year's cash flows are independent of the previous year's cash flows. Calculate expected total cash flows over a 4-year period and the 4-year volatility of the cash flows. Now, first of all, if the annual cash flows are expected to be $250,000 each year, and we're considering this over a 4-year period, then the 4-year expected cash flows will simply be 4 times 250,000, which is $1 million. What we have here is an expected annual cash flow of $250,000 with a standard deviation of $24,000. Now what this means is there's a 34% chance that you might be 1 standard deviation below the mean. Now that can mean that within the first year, instead of getting $250,000, it might be $24,000 less than that. But what if after the second year you're $24,000 below again, and the third year you're below again, the fourth year you're below again, then instead of getting this $1 million after 4 years, you might actually be $96,000 less than that particular value. Now the thing is though, based on what we've just calculated looking at Monte Carlo simulations, the likelihood of getting this figure of 24,000 below the first year and 24,000 below the second year and the third year and the fourth year is particularly unlikely given the nature of normal distribution that says that half the time you'll be below it and half the time you'll be above it. So it's very unlikely that you're going to get this 24,000 below 1 year and again the following years. Chances are at some point you're bound to be above it slightly, which could ultimately balance it out. What we need to do then, therefore, is work out how volatile this is going to be over the whole 4-year period. So if we were to use that formula, looking at the standard deviation over the long period. So what we're doing here is looking at how volatile is it going to be over the 4-year cycle. It's going to be the standard deviation over the shorter period multiplied by the time difference between the long period and the short period rooted. So the standard deviation over the short period is $24,000 multiplied by, well, the standard deviation that we've currently got, the short period, is for 1 year. The longer period we are considering is 4 years, and there's obviously 4 one-year periods in 4 years. So 24,000 multiplied by the square root of 4. Square root of 4 is 2, and therefore we have a standard deviation of 48,000. What this is basically saying, over a 4-year period, the standard deviation isn't simply going to multiply by 4. Chances are, over time, downward variations could balance themselves out against upwards variations, and as a result of it, the spread isn't going to be quite as big.